Hello, so in this video we're gonna do some questions. This probably will be the final video on binomial expansions, and we're gonna solve some questions related to binomial coefficients and finding the nth term and so on. So let's quickly review over the formulas that we need. So we know how to expand using the Pascal's triangle, but if you want to expand using the binomial theorem, the binomial expansion, then this is how you are going to do it. A plus b to the power n is going to be nc0 a to the power n plus n1 a to the power, and then you're gonna subtract 1, so you're gonna do the up minus the down. So the upper coefficient minus the lower coefficient, so a to the power n minus 1, and b is always going to be raised to the lower coefficient. So in this case, b is to the power 0, which is just 1, so that's why we don't write it here. And then we have n2 a to the power n minus 2 b squared, and so on. And if you notice, the power of a is going to decrease and the power of b is going to increase. And you're going to do this up until you get to nn. And then a to the power n minus n, that is a to the power 0, which is just 1, and you have b to the power n. So this is the binomial theorem. Now, what is this? What are these coefficients that we're writing? Well, nk, which we also say n choose k. And the meaning of this would be if you have n items, if we have n items, in how many ways can we select k items? So let me give you an example. Well, suppose I say I have 3 items, right? Now let's do the possible selections. So let me call this 1, let me call this A1, let me call this A2, let me call this A3. So let's list down the different possible selections. So I have 3 items. In how many ways can I select 2? Well, I can select A1, I can select A1 and A2, I can select A1 and A3, and I can select A2 and A3. So those are the possible ways of selecting 2 items from 3. So this tells me that if I have 3 items and I need to select 2, then there are 3 different ways. Now, if I have n choose k, the formula is given by n factorial divided by n minus k factorial times k factorial. And we have looked at factorials before, but just a quick recap is that n factorial is n times n minus 1 times n minus 2 all the way up until 1. So that is n factorial. So if I evaluate this using the formula, you get 3 factorial divided by 3 minus 2 factorial times 2 factorial. And 3 minus 2 is just 1. 1 factorial is 1. And 3 divided by 2 factorial is just going to give you 3. Because 3 is 3 times 2 times 1. And 2 factorial is 2 times 1. So these are going to cancel out. So you get 3, which is exactly what we have here. 3 different ways. Now let's review some additional formulas that are useful. So nk is the same as n choose n minus k. And this is very important. That is why we have symmetry. That is why, for example, in the Pascal's triangle, you see that the end numbers are always the same. n3, 3, 1. See, these numbers are the same because of this formula, because of this property of binomial coefficients. And well, why does this work? Well, the intuition is that if I'm selecting k objects, so if I have 3 objects and I'm selecting 2, I'm looking at number of ways to select 2, then well, that's like saying I automatically select 1, right? So being chosen, selecting 2, is also the same as not being chosen, selecting 1. So it's this case that gives us that, hey, n choose k is going to be equal to n choose n minus k. And the final formula that will be very important for our calculations is the nth term. So we looked at the derivation, we looked at the idea. So the nth term of a binomial sequence is given by n choose the n plus 1th term. So t n plus 1 is given by, and you substitute, your n ranges from 0 up until, sorry, the k plus, let's call it the k plus 1th term of a binomial expansion. So your k ranges from 0 up until n. So if you are expanding this a plus b to the power n, that will have n plus 1 terms. And you can see it here. I have one term. I will use the lower coefficient to count. I have one term here. I have the second term here. On and all, I have n terms here. And plus, I have this extra term. So that gives me n plus 1 terms, right? So I will substitute, so my k is going to range from 0 to n. So the k plus 1th term is n choose k. And then we have a to the power n minus k and b to the power k. And this is similar to what we have done before. And you want to remember this formula. This is very, very important. And now that we have everything down, let's solve some questions. So without using a calculator, find the value of each of the following. So 7 choose 3. That is 7 factorial divided by 7 minus 3 factorial times 3 factorial. So 7 factorial, I can write it as 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you notice, this is 3 factorial. So this cancels out with this. And 7 minus 3 is 4 factorial. And 4 factorial, I can write it as 4 times 3 times 2 times 1. So 4 and 4 will cancel out. 3 times 2 is 6, cancels out with 6. And 7, 5, I get 35. Now here's another way to do these questions. If you think the formula is a bit too complicated, here's what you can do. You want to use your lower term as a counter. So you're going to say you start with 7 times 6 times 5. And the minute I have 3 terms, I'm going to stop. So 7 times 6 times 5, I stop, and then I divide by 3 factorial. So this will give you the same result. So this is 3 factorial, 3 times 2 times 1. 3 times 2 is 6. 6 cancels out, so you get 35 again. This is a bit easier to do than to use the whole formula. So B, I have n choose 6. Well, this is a bit harder to compute, but we just said that it's the same as 9 choose 9 minus 6. N choose k is the same as n choose n minus k. So we're going to use this, and this gives me 9 choose 3. And this is easier to compute. So I can say 9 times 8 times 7. I have 3 terms, so I stop, divided by 3 factorial. So 3 times 2. Well, 9 is just 3 times 3. 8 is 4 times 2. So 2 and 2 cancel out, 3 and 3 cancels out. So I have 3 times 4 times 7. So 12 times 7 gives me 84. That is my answer. So I think I'll leave you to do C, and let's do D. So we have 15 choose 6. 15 times, and actually, so it asks you to not use a calculator, but you can definitely use a calculator if you ever have to perform it in the exam. So we have 15 choose 6. So I have 15 times 14 times 13 times 12 times 11 times 10. And that is 1, 2, 3, 4, 5, 6 terms. And I divide everything by 6 factorial. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Well, let's see. 15 is 5 times 3. 12 is 6 times 2. Now I have this 4. Can I divide anything here by 4? Well, not exactly. So let's say 4 is 2 times 2, right? So 4, I can write it as 2 times 2. 10 is 5 times 2. 14 is 7 times 2. So these 2's and these 2's are going to cancel out. So I have 7 times 13 times 11 times 5. And this you can compute without using a calculator. 11 times 5, that is just 55. 7 times 13, that is 21, that is 91. So you have 91 times 55, which we can compute manually. 5 times 1 is 5, 9 5s are 45, 5 times 1 is 5, 9 5s are 45. So you have 5, 5 plus 5 is 10, and then you add a 1 here, that gives me 10 again, you add a 1 here. So you have 5005 to be your answer. And let me just check along the way so that we make sure I teach nothing wrong. So we have 5005. That is your answer. That is correct. 5005. Now, express each of the following in terms of n. Well, you can use the same idea that we have been doing before. N, you subtract 1, and that is 2 terms. That is enough. And I divide by 2 factorial. And 2 factorial is just 2. And that is what they want. N choose 1. That is always going to be n. And n choose 3. Well, think about it. It's n, 1 term. And then I divide by 1 factorial. That is just n. And n choose 3. That is n times n minus 1 times n minus 2. And then you divide by 3 factorial. 3 factorial is just 6. So those are your answers. And the third question says, use the formula to find each of the following. All right. So that is 10 factorial divided by 10 minus 2 is 8 factorial times 2 factorial, right? And 10, I can write it as 10 times 9 times 8 times 7. Everything else is just going to be 8 factorial, if you think about it. So these will cancel out. And 2 factorial, well, 10 is just 5 times 2. So that gives me 45. 8 choose 5. That is harder to do. This is equal to 8 choose 8 minus 5. And that is just 3. And 8 choose 3 is going to be 8 factorial divided by 5 factorial. 8 minus 5 is 3. 8 minus 3 is 5 over 3 factorial, right? And if you just started with this, you're going to get this expression as well. So you have 8 times 7 times 6 times 5 factorial divided by 5 factorial times 3 factorial. You cancel these out. 3 factorial is just 6. And then you have 7, 8. That is just 56. So I'll leave you to try C and D because these are very basic questions. Now let's do question 4. So it says find in ascending powers of x the first 3 terms. So we just want to do first 3 terms. So let me do part A. Or let's not do A. I'll leave A to you. I'll do part B. I'll do part H. And I'll do part, let's just say E. So B tells me, for B, I have 1 minus 3x to the power 10. And we want to use the binomial formula. So I start with 10C0, right? And it says, remember, it says in ascending powers of x. So we're going to start with no power of x, and then we're going to increase our excess power. So this is the correct way to go. 10C0, I'm going to have 1 to the power 10 minus 0, which is just 10. And that is just 1, right? And then I'm going to have negative 3x to the power 0. And this is from the formula that we have been using before. Plus 10C1, 1 to the power 10 minus 1 is 9, minus 3x to the power 1. And finally, I have 10C2, 1 to the power 8, and then minus 3x to the power 2. On and on. Those are our first 3 terms. So 10C0, I have 10 items. In how many ways can I select no item? In just one way. Because the only way to do that is just not selecting anything. So that is 1 times negative 3x to the power 0 is also 1. Plus 10C1 is 10, and then I have minus 3x. And 10C2, well, that is 10 times 9 divided by 2 factorial. So that gives me 45 times minus 3x squared. And on and on. 1, I get minus 30x. And then here I get 45 times 9. That is plus 405 because negative 3 squared is positive, x squared. And those are my first 3 terms. Minus 30x and plus 405x squared. All right. Let's do part E. Part E tells me, well, if I have 3 plus x over 2 to the power 7, and then I need to do it in ascending powers of x again. So suppose I had the other way. Addition, it doesn't matter whether you do 2 plus 3 or 3 plus 2, you get the same answer, right? So if I switch the order and I expand this, Well, when I expand this, I'm going to start with the highest power of x, right? So if the question said descending powers of x, I would want to rearrange my terms. If it's ascending powers of x, then this way will be the correct way, because I'm going to start with x over 2 to the power 0, and then I'm going to go to x over 2 to the power 1, and so on. So ascending means in the increasing powers. So now I have, well, 7 choose 0, 3 to the power 7, and x over 2 to the power 0, that is just 1, right? 7c1, 3 to the power 6, 7 minus 1 is 6, x over 2 to the power 1. And finally, I have 7c2, 3 to the power 5 times x over 2 squared. So that's going to be my first three terms. 7c0 is 1, 3 to the power 7 is 2187. Plus 7c1 is just 7 times 3 to the power of 6 gives me 5103. I have then x over 2. So that is 5103 divided by 2 times x. And finally, I have 7c2. So that is just 7 times 6 divided by 2. That is 7 times 3. That is 21 times 3 to the power 5. 21 times 3 to the power 5 gives me 5103. And then I have x squared divided by 4 from here. So that is just 5103 divided by 4 times x squared. So that is going to be my first three terms for part E. And let me just quickly check it for you. Yes, 2187, 5103 by 2x, and then that is your answer. Now, let's do part H. 2 plus x squared by 2 to the power 9. And that is, we're going to do the same thing. 9c0, 2 to the power 9. And then the other is going to be raised to 0, which is just 1. I have 9c1, 2 to the power 8. X squared by 2 to the power 1. And finally, I have 9c2, 2 to the power 7. X squared over 2 to the power 2. 2 to the power 9 is going to be 512. Plus 9c1, that is just 9 times 2 to the power 8 is 2304 divided by 2 from here. And then I have x squared. So if I divide by 2, I get 1152. And finally, I have 9c2. 9c2 is 9 times 8 divided by 2. That is 9 times 4. And that is 36 times 2 to the power 7 times x to the power 4, because 2 times 2 is 4. And then I have 2 to the power 2, that is just 4. So if I divide 36 by 4, I get 9. And finally, 9 times 2 to the power 7 gives me 1152. X to the power 4. So that is your answer. So now it says find the coefficient of x3. So we're not going to do all of them. Let me do C, and I'll do 6 and 7, because that's essentially asking you the same type of questions. So I'll leave A, B, and D for you to try on your own. So find the coefficient of x cubed in each of the following expansions. So I am given the expansion of 2 plus x over 4 to the power 7. So we are going to use the r plus 1 or the k plus 1 term. Is n choose r, a to the power n minus r, b to the power r. And in this case, this is a, this is b. So we know that n is this. So 7 choose r, a is just 2. So I have 2 to the power, what is n minus r? That is going to be 7 minus r. And I have b is x over 4 to the power r. So that is 7r, 2 to the power 7 minus r times x to the power r divided by, well, 4 is just 2 squared, right? Times r is just 2 to the power 2r. And we can simplify this. That is 7 choose r, 2, 7 minus r minus 2r. So that is 7 minus 3r. And then I have x to the power r. So now it says the coefficient of x cubed. So I want to say, well, suppose to have x cubed here, my r needs to be 3. So that's the value of r I'm going to choose. Therefore, the coefficient is going to be everything here. So that is 7 choose 3 2 to the power 7 minus 3 times 3, that is 9. Right? So on your calculator, you can press 7, and then you can, if you press shift 1, that gives you the C arrow. And if you press 3 afterwards, that's going to give you the value of 7, choose 3. So that is 35 times 2 to the power minus 2. That is 35 by 4. 35 by 4 is the coefficient. So let's do question 6. Find the coefficient of x to the power 4. Well, let's use the general term. TR plus 1 is equal to n choose r, a to the power n minus r, b to the power r. So x to the power 4. All right, so we have, this is going to be a, this is going to be b, right? So we have, this is n. So 12 choose r, 2x to the power 12 minus r, right? And then b is just 1 to the power r. So we have 12 choose r, 2 to the power 12 minus r times x to the power 12 minus r. So I'm just distributing the powers here. And I want to find the coefficient of, this has to be equal to x to the power 4. So 12 minus r has to equal to 4, and therefore r is equal to 12 minus 4. If you simplify, you get 8. So therefore, your coefficient is going to be everything in the front that's not connected to x. So you have 12 choose 8 is 2 to the power 12 minus 8 is 4. And remember, 12 choose 8 is going to be same as 12 choose 12 minus 8. So 12 choose 4. This is easier to calculate, but you can always put it in your calculator. So you can press 12, shift 1, and 4, and times 2 to the power 4. That gives you 7920. And yep, that's the answer for question 6. And question 7 is essentially asking you to do the same thing. So I'll actually leave question 7 for you because it's the same thing, the same formula for finding the nth term. And we have also used that in the previous one. So let's do question 8 because that looks more interesting. It says, find the coefficient of this thing in the expansion of this. So we do the same thing. We have our r plus 1 term is always going to be n choose r, a to the power n minus r, b to the power r. So x is my a, minus 2i is my b. So I have 13 choose r, because n is equal to 13, x to the power 13 minus r, and minus 2y to the power r, right? 13 choose r, x to the power 13 minus r, and then from this I have minus 2 to the power r, the first term raised to r, and y to the power r. Now, let me isolate. So I want to look at y to the power r, so I want to look at this. X to the power 13 minus r, y to the power r should equal to x to the power 8, y to the power 5, right? So suppose I select r is equal to 5. Then this becomes 5, and 13 minus 5 is just 8. So I want r5. Now, if I evaluate the coefficient, that is going to be everything that is not connected to variables. So the coefficient is 13 choose 5 minus 2 to the power 5. So if I use my calculator, 13 choose 5 times negative 2 to the power 5, that gives me negative 41184. And that is your answer. That is the coefficient. Now, this is another type of question that you can see, which is find the term independent of x. So what does that mean? Well, the term independent of x just means that when I expand this, I'm going to get some constant term. And what is that constant term? Well, the procedure is exactly the same. So my TR plus 1, and rewriting the formula will help you to remember it, is NCR n minus r, b to the power r. So this is my a, this is my b. So I have 12, choose r, x to the power 12 minus r, and b is negative 3 over x squared to the power r. Now let's simplify. I have 12, choose r, x to the power 12 minus r, and in the numerator I have minus 3 to the power r. In the denominator, So I'm clubbing the negative with the numerator. X to the power square times r, that is 2r, right? And I can simplify this further. I have 12r minus 3 to the power r. That is going to be my coefficient term. And I have x to the power 12 minus r divided by x to the power 2r. And that is minus r minus 2r using the laws of exponents. So I have x to the power 12 minus 3r. And I want x to the power 0. That is the only way I can get something that is a constant, because x to the power 0 is 1. So what r do I need to select? Well, if I select r is equal to 4, 3 4s are 12, so this is going to become 0. So r is going to be 4. And minus 3 to the power 4. So if I use my calculator, times negative 3 to the power 4 gives me 40095. That is your term independent of x. So that is how you do these questions. Now it says, find in ascending powers of x the first 3 terms of each of the following expansions. So it just says in increasing powers of x. So let's do, so I'll do, let's say, a and b. So you can try, I'll do b and c. You can try a on your own. So b gives me 1 plus 2x, and I have 1 minus 3x to the power 10. So we can use the binomial theorem to expand the second term. So I have 1 plus 2x, and I'm not going to do the whole expansion. I'm going to stop when I feel it's appropriate. So I have 10c0. This is another way to write 10, 0. 1 to the power 10, right? And because my term is 1, so I don't really need to write 1 to the power any, because that is always going to be 1. So I start with negative 3x, that is b to the power 0. So that is also 1 as well. So this to the power 0 is going to give me 1. Plus 10c1, I don't need to do 1 to the power 9. That is always just 1. Minus 3x to the power 1. And finally 10c2 minus 3x squared. And I can go on and on, but I'm not going to. 1 plus 2x, 10c0 is 1, plus this is going to give me negative 30x if you simplify, and 10c2. So that is 10 times 5 times 9, that is 45. So plus 45 times minus 3 squared is 9 times x squared, right? And 45 times 9 gives you 405. 405x squared, and it goes on. The expansion has not ended here yet. But if I multiply these out, I'm going to get 1 minus 30x. I multiply everything here with 1 plus 405x squared plus I multiply everything with 2x. So 2x minus 60x squared, right? And the third multiplication is going to give me plus 810 x cubed, and on and on. And now I can add these. So the first 3 terms in ascending powers is going to be x to the power 0, x to the power 1, and x to the power 2. So I have 1 minus 30x plus 2x minus 28x plus 405x squared minus 60x squared. And that gives me plus 345x squared. So that is going to be the first 3 terms in ascending powers of x. And let me change the color. I've been writing in pink for so long. Okay. So C. C is essentially the same thing. I have 1 plus x, and I want 1 minus x over 2 to the power 10. So I keep my first term, I expand the second term, and because it's 1 again, so I don't really need to care about 1 to the power 10, 9, because that's always going to be 1. So I have 10c0 plus 10c1 minus x over 2 to the power 1 plus 10c2 minus x over 2 to the power 2, and so on. So 1 plus x, 1 plus, this is 10 choose 1 is 10, divided by 2 is going to give me minus 5x 10 choose 2 is 45 divided by 4. So I have 45 divided by 4x squared. And I encourage you to simplify on your own. And now I have 1 minus 5x plus 45 over 4x squared. When I multiply with 1 with all three terms, dot, dot, dot. Plus if I multiply with x, I have x minus 5x squared plus 45 by 4x cubed, dot, dot, dot. So 1, and I'm not going to need x squared because the first three terms is just going to be x to the power 0, x to the power 1, and x to the power 2. So minus 5x plus x, that is minus 4x. And I have plus 45 by 4x squared minus 5x squared. Well, 5x squared is just 20 over 4x squared. And if I simplify this, I get 25 by 4x squared, and it goes on. I'm so sorry. This was 8. So we have to replace everything with 8 here. So I misread the question. So that is going to change our answer. So sorry about that. 1 plus x, that does not change, but the expansion changes. 8c0 is still 1, plus 8c1 is 8. Divided by 2, that is going to be minus 4x. And 8 choose 2, that is 8 times 7 divided by 2. 4 times 7, that is 28 by 4. I think. That is 28. And then I have x squared divided by 4. And on, right? And that is just 14 by 2. That is 7. So I have 7x squared here, on and on. So if I simplify, I get 1 minus 4x plus 7x squared, on and on, plus x minus 4x squared plus 7x cubed. And I don't need x cubed. So 1 is the same, minus 4x plus x minus 3x plus 7x squared minus 4x squared plus 3x squared. So that is your first three terms. So question 12 is actually, if you think 12a is the same thing, right? So 12a asks you for the same thing, and it says, hence obtain the coefficient of x squared in the expansion of this. So they give you something extra. Well, let's go back. Because I already expanded this thing. Here, it's the same thing. So let's directly jump to 12. We have already done a. So because the ascending powers of x, that is just this thing. X minus 4x squared plus 7x cubed. That is in ascending powers of x, the expansion of that thing. Hence, obtain the coefficient of x squared. So I'm multiplying this thing basically by 2 minus 3x, 2 plus 3x minus x squared. Now let's think about this. How can I get x squared? Well, I can multiply 2 with x squared. I get minus 8x squared. I can multiply 3x with x. That is going to give me an x squared term. Plus 3x squared. Is there anything I can multiply minus x squared with to get x squared? Well, no. The only thing I could multiply with is a constant, but I don't have a constant in my second term. So that is just going to be minus 5x squared. So that is your answer. Did I make a mistake? I think I did. So is there anything I'm missing here? No. So let's try again. I'm so sorry about that. Unless I did my expansion wrong from the previous question. Which I don't think I did. Anyhow, let's just do it manually. So 12a tells me find in ascending powers of x the first three terms in the expansion of. So I have been given 1 minus x over 2 to the power 8. So if I expand this, I'm going to get 8c0, 1, minus 8c1, plus 8c1 minus x over 2 to the power 1, plus 8c2 minus x over 2 squared, and on and on. So that is going to give me 1 minus 4x plus 8c2, that is 28 by 4, plus 7x squared. So that should be my answer for 12 part A. And now it says, hence obtain the coefficient of x squared in the expansion of this thing. So I have 2 plus 3x minus x squared, and 1 minus the expansion just gives me 1 minus 4x plus 7x squared, on and on. So 2 times 1 is 2 minus, so I don't need to do all the calculations. I can just do, well, see, I can multiply 7 and 2. That gives me an x squared term, right? So I think I copied the question wrong the first time I did it. So if I multiply 7x squared times 2, that gives me 14x squared. Now, how else can I get an x squared term? 3x if I multiply 3x times negative 4x, that gives me an x squared term. So I have 3 times negative 4, negative 12x squared. And finally, if I multiply negative x squared by 1, that is going to give me an x squared term. So that is just 1. That just gives me 1x squared. So the coefficient is 1. So I'm so sorry. I think I copied the question wrong the first time. So the answer is 1. So we have done 12. So now these are like more questions, then these are slightly more complicated because now we're doing some more algebra. So let's do 13. Actually, should we do 11 first? Let's do 11 first. So 11a tells me find the expansion of 2 plus x to the power 10. And that is 10 choose 0, 2 to the power 10, right? 10 choose 1, 2 to the power 9, x to the power 1, plus 10 choose 2, 2 to the power 8, x to the power 2. And now we have to simplify. So that is 2 to the power 10 is 1024 plus 10 times 2 to the power 9. So 2 to the power 9 times 10 is 5120x plus 10c2 is 45 times 2 to the power 8 is 11520x squared. And the expansion continues. So that is the first three terms for 11a. By replacing x with this thing, find the three terms in the expansion of this. Well, it says I want to replace x with 2y minus y squared. 2y minus y, 2y minus 3y squared, I believe. So I replaced x here with 2y minus 3y squared to get the first three terms in the expansion of this to the power 10. So that is still going to be, I don't have any x here, so that is just going to be 1024 plus 5120. Instead of x, I'm going to substitute 2y minus 3y squared plus 11520. And usually, if they ask me to find something in A, which was this, I'm probably going to be using that in B. So I don't have to expand everything again. Squared, and so on. So if I simplify this, 1024 plus this thing is going to give me, so 10,240, that is this, times y, minus 06315, that is y squared. So if I multiply 5120 inside the bracket, that is what I will get. Plus 11520, I need to expand this out first. So you can use the binomial theorem again, or you can use, let me just give you a plus b, that is a formula worth memorizing. A squared plus 2ab plus b squared, right? we're going to get first term squared, that is going to be 4y squared, and then I multiply my first and the second term, right? 2y times negative 3y squared, that is negative 6y cubed. And I multiply this by 2 again. So negative 12y cubed. So that is 2. So I did AB first, and then I multiply by 2 to get 2AB. Plus 9y to the power of 4. And so on. This b squared is 9y to the power of 4. So it says the first 3 terms, right? So the first 3 terms is just going to involve y to the power 0, y to the power 1, and y to the power 2. So I don't need these actually. So I stop at 1024 plus 10240y minus 15360y squared, and then I multiply this. 11520 times 4 is 46080y squared. And if I simplify these two terms, so I need to do 46080 minus 15360. That gives me plus 10240y plus 30720y squared. That should be your answer. So let me quickly check it for you. 11b is 1024 plus 10240y plus 30720y squared. That is exactly the answer. So now 13 is a bit more complicated. It says, to find the first 3 terms in ascending powers of x in the expansion of this. So what we want to do is we want to binomially expand both terms. So I have 2 minus 3x to the power. So because I only need the first 3 terms, I'm only going to get until I have x here, I have x here. So the first 3 terms is going to involve x to the power 0, x to the power 1, and x to the power 2, right? So I just need to do 3 terms for each. So 4c0, 2 to the power 4, plus 4c1, 2 to the power 3, minus 3x, plus 4c2, 2 to the power 2, minus 3x squared. I can stop here. 4c0 is just 1, 2 to the power 4 is 16, plus 2 to the power 3 is 8, 8 4s are 32, minus 32 times negative 3 is negative 96. X plus 4 choose 2. 4 choose 2 is 6, I believe. I think so. Yeah, 4 choose 2 is 6. 6 times 4 is 24. 24 times 9. 24 times 9 gives me 216 x squared. That is my third term. Now I need to expand my other term. So I will expand 1 plus 2x to the power 10. 1 plus 2x to the power 10. So that is just going to be 10c1, 10c0, 1 to the power 10 is just 1. And I have 10c1, 2x to the power 1. Finally, 10c2, 2x to the power 2. And so on. So that gives me 1 plus 20x plus 45 times 4. That is 180 x squared. And so on. And now I need to multiply these two together. So I have 16 minus 96x plus 216x squared, on and on, times 1 plus 20x plus 180x squared, on and on. So now I need up until x squared, right? So 16 I can multiply with all 3 terms. My answer will still be up until x squared. So 16 times 1 is 16, plus 16 times, that is going to be 320x, and then 16 times 180 gives me 2880x squared. Now I can take minus 96 and I can multiply with only the first 2 terms. If I multiply minus 96x with the third term, I'm going to get something x cubed. And I don't want x cubed because it only asks me for first 3 terms. If it asks for first 4 terms, then I would need x cubed. So minus 96x minus 96 times 20 is minus 1920 x squared. And finally, I can multiply 216x squared with 1. And if I multiply here, I get x cubed, which I don't want, and dot, dot, dot. So I get 16, 320 minus 96x. 320x minus 96x is plus 224x. And these three terms simplifying gives me 2880 minus 1920 plus 216 is 1176x squared. So that is the answer for 13. Just tells me the first four terms in ascending powers of x in the expansion of this thing are, so I need up until x cubed. So I have this expression, 1 plus ax plus bx squared to the power 7. So let's just say the second term, ax plus bx squared is y. So I'm saying ax plus bx squared is equal to y. Now this is an easier expansion, right? And let's expand to the first. So if we wanted x squared, we were expanding to first three terms. So we want x to the power 4. So I think it's safe to expand to the first four terms. So the first four term is going to be 7c0 plus 7c1. I have 1, so I don't really care. If I had -1, I would be caring because the signs are going to change. But 1 to the power anything is just going to give me 1. So y1 plus 7c2, y squared plus 7c3, y cubed, and so on. So that is just going to be 1 plus 7y plus 7c2, that is 21y squared, I believe, because that is 7 times 6 by 2, 7 times 3 is 21, and 7c3 is 7 times 6 times 5 divided by 3 factorial. 3 factorial is just 6, so 7 5 is 35 y cubed, and so on. And now I can substitute this inside my expression. So I get 1 plus 7, I have ax plus bx squared plus 21 ax plus bx cubed, bx squared, right? Because I have, and then finally I have 35 ax plus bx squared cubed. Now this is ugly, but we have to solve this. So I can directly multiply 7 inside the bracket. That is not an issue. 7 times ax is 7ax plus 7bx squared. 21. Well, I can easily expand this because that is just a plus b whole squared. So a squared is a squared x squared plus, I have to multiply these two terms together. So I would get abx cubed, right? A times b is ab, x times x squared is x cubed, and I need to multiply the whole thing by 2 because I have 2ab in the formula. And finally, if I say this is b, b squared is b squared x to the power 4 plus 35. Now I need to expand this. Now you can use the binomial theorem, and I encourage you to do that, but I want to do it a bit quickly. So it's going to be the first term cubed, that is a cubed x cubed. And I think I can stop. And the reason for that is, oh wait, the second term is going to be a3, it's going to be ax squared bx squared. So you can do binomial expansion, you can expand it on your own. I'm doing it a bit quickly here, and it goes on. And if I think about it, this is going to give me x to the power 4. And the question only asks me to stop when I get to x to the power 3, right? And the next term is going to be 3ax bx squared squared. So that is x to the power 4 times 1 is x to the power 5. And I'm going to end at x to the power 6. So I don't need that. I only need up until x to the power 3. So I don't really have to expand. I can stop here. So now I can add these. I can simplify. 1 plus, I have 7ax here, plus 7bx squared, plus 21a squared x squared, plus 42ab x cubed. I don't need this because x to the power 4 is not required. And I have 35a cubed x cubed. So now if I simplify, I get 1 plus 7ax is the only term with an is the only term containing an x, so 7ax, plus I have 7bx squared plus 21a squared x squared plus, so that is it. And I want to factor out my x squared. And finally, I have 42ab x cubed plus 35a cubed x cubed. So I want to factor out an x cubed. Now what does that tell me? The question says, I want to find the value of a, b, and p, right? So I am given the first term is 1, that is okay. The second term is negative 14. So 7ax is equal to negative 14x. And therefore 7a has to be equal to, if I cancel out the x's, I get 7a is equal to negative 14 and a is equal to negative 2. So I get a is equal to negative 2 as my answer. And from the third part, I see that, hey, 91x squared has to equal to this thing, right? Or you can just compare the coefficient and say that 91 is equal to 7b plus 21a squared. Minus 2 squared is 4. So if I simplify this, 21 times 4 and 91 minus 21 times 4 gives me 7. So 7b is 7, b is going to be 1. And finally, to calculate the value of p, well, p is just this. So I have p is equal to 42 times negative 2 times 1 plus 35 times negative 2 cubed. And that is minus 84 minus 35 times 8. And that simplifies to minus 84 minus 35 times 8 simplifies to negative 364. That is your p-value. And so we're almost done.